Cayley-Hamilton theorem. That's how you get the question in part B. So for verifying Cayley-Hamilton theorem, what you have to do is you have to prove either a square minus c1a plus c2a is equal to 0, or you have to prove a cube minus c1a square plus c2a minus c3i is equal to 0. So in the case of part B, you will be getting only matrix of order 3. So only you'll be getting problems of order 3 problems only you'll be getting in part B. So apart from verifying Cayley-Hamilton theorem, you have two more applications of Cayley-Hamilton theorem. One is you can find the inverse of the matrix with the help of Cayley-Hamilton theorem. And the number 2 is you can find the power of the given matrix by using Cayley-Hamilton theorem. So how we are going to find the inverses? For finding the inverse of the given matrix, you have to take the equations, the two equations which have been there in the slide. So multiply the equations by A inverse. When you multiply the equations by A inverse, then you will be able to find out the inverse of the given matrix, depending upon whether it is a 2 by 2 matrix or a 3 by 3 matrix. Like that, if power of A is required in the question, then what you should do is you have to multiply by A the two equations, depending upon whether it is a 2 by 2 matrix or 3 by 3 matrix. So since part B involves only matrix of order 3, I will explain how to verify Cayley-Hamilton theorem and how to find A inverse and the power of A with the help of Cayley-Hamilton theorem. So we'll just move to the next problem. There is the next slide which gives the problem. Yeah. So the question is, prove that the matrix, you have been given a 3 by 3 matrix, satisfies its own characteristic equation. Meaning you have to verify Cayley-Hamilton theorem and hence find A power 4 and A inverse. So this is be a standard question. In this question, I have included both A power 4 as well as A inverse. So sometimes you'll be asked only A inverse, sometimes you'll be asked only A power 4, and sometimes both might be asked. So the very first step in proving this is I have to first define the characteristic equation. So since A is a 3 by 3 matrix, what is the general characteristic equation form? Lambda cube minus C1 lambda square plus C2 lambda minus C3 equals 0. Already I have discussed in the previous slide. So we have to find out the values of C1, C2 and C3. So already you know the definition for C1, C2, C3. What are the definitions for C1, C2, C3? C1 is nothing but sum of the diagonal elements of the given matrix A. So in the given matrix A, the diagonal elements are 1, 1, 1, and therefore its sum is 3. So that is the value of C1. Next is C2. What is C2 definition? C2 definition is actually sum of the minors of the diagonal elements of the matrix A. So what do you mean by a minor of an element? If I want to find a minor of any element in a matrix, I have to leave the row and the column containing that element and find the determinant of the remaining one. Yes, so I'll continue. So what is C2? C2 is minors of sum of the minors of the diagonal elements. Here, what are the diagonal elements? 1, 1, 1 are the diagonal elements. So I'll take the first diagonal element. First diagonal element is 1. If I want the minor of this one, what should I do is I have to delete or remove the row containing 1 and the column containing 1. So when I remove the row containing the first diagonal element and the column containing the first diagonal element, I will be left with a 2 by 2 matrix. What is that? 1, minus 1, minus 1 and 1. So take the determinant of the first one plus take the second one. Second one is second diagonal element is also equal to 1. Second diagonal is also equal to 1. Its minor is obtained by removing that row and that column elements. So you'll be left with 1, 3, 1, 1, right? Plus third one. Third one is the third minor of the third diagonal element. Third diagonal element is also 1 in this problem. So minor of the third diagonal element, if I want, means leave that row and that column. So what is remaining is 1, 0, 2, 1. Now, when I find determinant values of these three, and when I add it, I'll be getting the answer as -1. So all these calculations you can just check later. Then finally, to find out this value of C3, I have to find out the determinant of the given matrix A. So I think you know how to find the determinant of the matrix. So the value of the determinant of the matrix is going to be -9. So after having find the values of C1, C2, C3, just substitute in the general equation. And the general equation takes the form lambda cube minus 3 lambda square plus C2 lambda becomes minus lambda and minus C3 becomes plus 9 equals 0. So the first step in verifying Cayley-Hamilton theorem is to obtain the characteristic equation. So we have got the characteristic equation of a 3 by 3 matrix, which is of degree 3, namely lambda cube minus 3 lambda square minus lambda plus 9 is equal to 0. So in order to verify Cayley-Hamilton theorem, what you have to do is actually you have to prove instead of lambda, put a. What you'll be getting a cube minus 3a square minus a plus 9i equals 0. This is what you have to prove, which means take the left hand side, simplify, and prove that the final answer is a 0 matrix. So what is your left hand side? Left hand side consists of 4 matrices. What are the 4 matrices you have? One is a cube, another one is 3a square, another one is a, and the fourth one is 9 times I. Okay. How will I find a cube? For finding a cube, I have to know what is a square. Then only then I can find out a cube. So what is a square? A square is nothing but matrix A into matrix A. So it is being written matrix A is 1, 0, 3, 2, 1, minus 1, 1, minus 1 into 1, 0, 3, 2, 1, minus 1, 1, minus 1. So how will you multiply the two matrices? The process of multiplication. When you multiply two matrices, the first row, first column element, if I want, I have to multiply the first row of the first matrix with the first column of the second matrix. So the first row of the first matrix is 1, 0, 3, and the first column of the second matrix is 1, 2, 1. When I multiply the corresponding elements and add it, what I'll be getting is 1 into 1 plus 0 into 2 plus 3 into 1. This is what I'll be getting. So when I add everything, I'll be getting the answer as 4. So 4 is the first row, first column element of a square. Similarly, if I want first row, second column element of a square, I should multiply first row of a and second column of b. And then multiply the corresponding elements and then add it. So what will you get? 1 into 0 plus 0 into 1 plus 3 into minus 1, which will be minus 3. So the first row, second column element is minus 3. So when you do like this, you will get a square as 4 minus 3, 6, 3, 2 minus 4, 0 minus 2, 5. So this is your A square matrix. Then you have to obtain A cube matrix. What is A cube matrix? A square matrix into A matrix. Same way, we multiply A square matrix with A matrix, we will be obtaining the A cube matrix. Now, for the left hand side, A square matrix is required, A matrix is required, A cube matrix is required. So all the three are now ready. What you should do is you have to simply substitute the matrix value. So first matrix is A cube. I have substituted A cube matrix. Then minus 3 times A square. What do you mean by 3 times A square means? 3 times A square is nothing but you have to multiply each and every element of A square by 3. So A square matrix is the first matrix, that is 4 minus 3, 6, 3, 2, 4, 0, minus 2, 5. Multiply each and every element of that matrix by 3. You will be getting 12, minus 9, 18, 9, 6, 12, 0, minus 6, and 15. Then minus A matrix, write the A matrix, plus next matrix is 9i. So what is 9i? Multiply I matrix. What is I matrix? 1, 0, 0, 0, 1, 0, 0, 0, 1. By, if you multiply each and every element by 9, you will be getting 9, 0, 0, 0, 9, 0, and 0, 0, 9. So what I have to do is just add and subtract these 4 matrices. How will I add and subtract matrices? I have to add and subtract the corresponding elements of these 4 matrices. When I do that process, I'll be getting all the elements as 0, which means the resulting answer is a 0 matrix, or in other words, we have proved that a cube minus 3a square plus minus a plus 9i equals 0. So the first part of the question, namely Cayley-Hamilton theorem, is verified. Next one is I have to find out a power 4 as well as a inverse. To find a power 4, what you should do, just do you remember the previous slide? What I should do, if I want to find a inverse, I have to multiply throughout by a inverse. If I want to find a power of a, I have to multiply by a. So this is your procedure. So based on this procedure, to find a power 4, I have to multiply that equation. Which equation? A cube minus 3a square minus a plus 9i. I have to multiply throughout by 4. So that is your equation 2. Equation 2 is a cube minus 3a square minus a plus 9i divided by is equal to 0. If I multiply throughout by a, what I will be getting is a power 4 minus 3a cube minus a square plus 9a equal to 0. From this, what is required is a power 4 is required. So keep a power 4 in one side, take the remaining terms to the other side. So you will get a power 4 as 3a cube plus a square minus 9a. As usual, what you should do is substitute the corresponding matrices. What is 3a cube means? 3 times of a cube matrix, that is the first matrix, plus a square matrix you write down, minus 9 times a matrix you write down. Add everything and subtract everything, you will be getting one final matrix, that is the value for a power 4. Then to find a inverse, what is the procedure? Multiply same equation number 2, namely a cube minus 3a square minus a plus 9i equal to 0 by a inverse. When you multiply the equation by a inverse, what will I get is every power will get reduced by 1. So I'll be getting it as a square minus 3a minus I plus 9a inverse is equal to 0. From that, you want a inverse. So keep a inverse in one side, take the remaining terms to the other side. So you'll be getting 9a inverse is equal to minus a square plus 3a plus I, or just substitute all the respective values. Minus of, write the a square matrix, then write 3a matrix, then I matrix, then add everything. You'll be getting one value. That is the value for 9a inverse. So a inverse is going to be 1 by 9 of this matrix. So this is the procedure. This is a very simple procedure. What you should do is you should know matrix multiplication and you should know the general formula for the characteristic equation. If that is done, then you can easily verify Cayley-Hamilton theorem, and based on that, you can also find out a inverse and a power 4. And please don't think that you will be getting the same matrix in the examination. You will be getting different matrices, but you will be getting a matrix of order 3 in part B only. So don't please expect the same matrix in the examination. Right. This is another example where I have verified the Cayley-Hamilton theorem for a 2 by 2 matrix. So the procedure is exactly the same. The only thing is the general form will be a second degree equation, and use the corresponding results. What is C1? What is C2? Then find the characteristic equation. After finding the characteristic equation, you have to verify the Cayley-Hamilton theorem. So just now how we have proved for a 3 by 3 matrix, in the same manner, you have to proceed for a 2 by 2 matrix also. First verify Cayley-Hamilton theorem. Then for finding A inverse, you have to multiply by A inverse. So if you are thorough with at least this Cayley-Hamilton theorem, this is going to be a definite question in your hard rate. So with this, I will move on to Unit 2. So before going to Unit 2, so Unit 2 is actually differential calculus. So as the name says, this unit definitely deals with differentiation. So unless you know a little bit of differentiation, you won't be able to solve problems in this second unit. So you should know the basics of differentiation. Namely, what is the basics of differentiation? Derivative of a constant is 0. Then derivative of a constant multiplied by a function is constant into derivative of the function. Then the addition rule and the subtraction rule of functions, the derivatives. Then the famous product rule under differentiation, which is u into dv by dx plus v into dv by dx, and the quotient rule under differentiation, namely v du by dx minus u dv by dx by v square, provided v is not equal to 0. So at least you should know these basics. And apart from this basics, you should also know derivatives of some standard functions. When I say standard functions, derivative of x power n is n into x power n minus 1. Derivative of all trigonometric functions, sin x, cos x, tan x, etc., etc., and derivative of e power x and derivative of log x, at least. If not inverse functions, at least you should be knowing derivative of x power n, derivative of e power x, and derivative of trigonometric functions. At least be thorough with these things. So only when you know the derivatives of these things, we can proceed to the next topic here. So in this unit, I'm going to deal with only one topic. As I told you, every unit I'll be taking only one topic, which is going to be a definite question in part B. So the topic that I'm going to deal in unit 2 is evolute. The evolute is a definite question in your part B. So I'm going to concentrate on evolute. But before going into evolute, you should know again some formulas are required. So I have given you 3 sets of formulas here. One is known as a radius of curvature. Then you have the center of curvature, and then you, of course, you have the circle of curvature. So it is recommended that you have to memorize these formulas. There is no other option. So in all these 3 cases, derivative exists. So what derivatives you are doing here? The first derivative, namely dy by dx, and the second derivative, namely d square y by dx square, is involved in all the 3 formulas, right? So radius of curvature formula is again very simple, which is denoted by rho, and it is defined as 1 plus dy by dx square, the whole power 3 by 2 divided by d square y by dx square. Any formula is valid only if denominator is non-zero, and therefore we insist that denominator is non-zero. And rho is always positive. Suppose if you get a negative answer, no need to worry. You consider the modulus value and give the answer as positive. And in this case, while calculating radius of curvature, you might get into a situation where your dy by dx becomes infinity for a specific value of x and for a specific value of y. In that case alone, your radius of curvature takes a modified form, which is 1 plus, instead of dy by dx, you will be writing it as dx by dy, square the whole power 3 by 2, and instead of d square y by dx square, you will be writing it as d square by dx square. So just remember this formula. And then one small tip regarding this radius of curvature is, if the given equation is a circle of radius r, then radius of curvature is equal to r. You need not calculate that. Directly you can give the answer as r. So this you can expect in the 2 marks question. So after finishing radius of curvature, then we will go on to center of curvature. So what is the center of curvature? Center of curvature is basically, it's a point whose x coordinate is x bar, y coordinate is y bar. And the formula for calculating x bar and y bar are given as x bar equals x minus y1 into 1 plus y1 square by y2, and y bar equals y plus 1 plus y1 square by y2, where y1 is dy by dx and y2 is d square y by dx square. So again, same thing only. You have to just find out the first derivative and second derivative and substitute those values and get the value of x bar and y bar. That coordinate is called as the center of curvature. And finally, you have circle of curvature. Circle of curvature is nothing but it is a circle whose center is x bar comma y bar and radius is rho, which is nothing but radius of curvature. So circle of curvature is a circle whose center is center of curvature and radius is radius of curvature. And the formula is given by x minus x bar the whole square plus y minus y bar the whole square equals r square. So we will move on to the next topic. Before going on to evolute, I will just do one problem under radius of curvature. We will see how to find out the radius of curvature when any curve is given. So the question is, find the radius of curvature at the point 3a, 2, 3a by 2, 3a by 2 on the curve x cube plus y cube is equal to 3xy. So you have been given one curve and you are asked to calculate the radius of curvature. So for finding the radius of curvature, whatever is required, dy by dx is required, d square y by dx square is required. So what I should do first thing is, I have to find out dy by dx. How will I get dy by dx? Only if I differentiate the equation, both sides with respect to x, I'll be getting dy by dx. So Okay, left hand side also has xy, right hand side also has xy terms. So differentiate left hand side as well as right hand side with respect to x. So take your left hand side. What do you have on the left hand side? You have x cube whose differentiation is 3x square. Then you have y cube whose differentiation is 3y square into dy by dx, because you have differentiate with respect to x, is equal to right hand side is 3a into xy you have, of which 3a is constant. So take the constant completely outside. What is balance is x into y. Since y is a function of x, x into y is of the product form. So you have to use the product rule. So remember, I told you already in the beginning, these are the basics of differentiation. So what is the product rule? X into derivative of y plus y into derivative of x, which is x into dy by dx plus y. So left hand side also has the term dy by dx. Right hand side also has the term dy by dx. So collect dy by dx terms and bring it to one side, and then find out dy by dx. So when you do that, you will be getting dy by dx as ay minus x square by y square minus x. So first derivative obtained. Now to obtain the second derivative, what should I do? I have to again differentiate this equation with respect to x on both sides. When I differentiate with respect to x on both sides, your left hand side becomes d square y by dx square. What about my right hand side? My right hand side is of the form u by v, that is quotient form. So I have to use the quotient rule of differentiation. What is the quotient rule? Denominator into differential of numerator minus numerator into differential of denominator by denominator square. So based on that, denominator is y square minus ax. Differentiation of numerator is a into dy by dx minus 2x, minus numerator is ay minus x square into denominator differentiation is 2y into dy by dx minus a by denominator square. So I can leave it as it is. I need not substitute dy by dx in d square y by dx square. Why? Because mainly is you are being given one point in the question. What is the point given? 3a by 2 and 3a by 2. Whenever a point is given in the question, you need not simplify d square y by dx square by substituting dy by dx. You can just substitute the point and get the value directly, right? So dy by dx is obtained, d square y by dx square is obtained, both obtained in terms of x and y. Now, since a point is given, substitute the point in both, that is in dy by dx expression as well as in d square y by dx square expression. In both these expressions, put x as 3a by 2, y as 3a by 2. When you do that, you will get dy by dx as minus 1 and d square y by dx square as minus 32 by 2. So all this is, you have to just substitute these values. So all those calculation parts, you can do it. So after finding out dy by dx value, d square by dx square value, write the formula for rho and then substitute the values in that formula, corresponding values. When you substitute, actually you'll be getting the answer in negative, but since rho has to be positive, I am taking the modulus sign. So rho value is 3 into root 2a by 6. So this is one just example problem I have given for radius of curvature. So whenever you are asked to find out the radius of curvature for any curve, what you should do is you find out dy by dx, d square y by dx square, and if any point is given, substitute that point, simplify dy by dx or d square y by dx square, and then use the formula and get radius of curvature. Similarly, when any curve is given, you can also find out center of curvature by using the formula for x bar and y bar after finding dy by dx and d square y by dx square. So once, whereas for all these three cases, first derivative and second derivative you have to find out, then use the formula, you will be getting the required answers. So next I'll move on to the main topic, which I've already told you, which is nothing but evolute. So what is evolute? Evolute is nothing but it is the locus of center of curvature. So this is the definition. This again can be asked in 2 marks. Define evolute. So you can say evolute is the locus of center of curvature. So what is the procedure for finding the evolute? There are 4 main steps to find the evolute. First step is, whenever you are given a curve, you have to write the parametric representation of the curve. What do you mean by a parametric representation of the curve? Curve means, first of all, when you have a curve equation, normally equation of a curve will be in terms of y and x. Generally, a curve equation will be in terms of y and x. Parametric representation means the equation won't be in terms of y and x. Instead, your x and y will be in terms of another variable which you normally call it as parameter t. That is why it is known as parametric representation. So step one is write the parametric representation of the given curve. So after writing the parametric representation of the given curve, next step is find x bar and y bar. Why I am finding x bar, y bar? Because evolute is defined as locus of center of curvature. So what I have to find out is center of curvature is what I have to find out for finding evolute. So what is center of curvature? X bar and y bar is the center of curvature. So I'm going to find out the step 2, x bar in terms of the parameter, y bar in terms of the parameter. Then step 3 is eliminate this parameter, whatever parameter you have, and get an equation in terms of x bar and y bar. Form an equation which involves only x bar and y bar and not the parameter. That is step 3. And last step is change x bar as x, y bar as y. That is going to be your evolute. And there is a meaning for locus. Locus means you have to change x bar and y bar as x and y in the equation containing x bar and y bar. So this is the procedure for evolute. Again, it's very simple. So before going into evolute, I will be giving, there are standard problems. In the 7 problems you have, standard problems under evolute. So you can expect any one question from these 7 problems. So I'll be giving you the parametric representation of these standard curves. So what are the standard curves that you have is 2 parabolas. One is the horizontal parabola, which is y square is equal to 4ax, and another one is the vertical parabola, which is x square is equal to 4ay. Then ellipse, hyperbola, rectangular hyperbola, asteroid. So these are the 6 curves, 6 standard curves for which I have given the parametric representation. So for the horizontal parabola, the parametric representation is x is equal to 80 square, y is equal to 280. For the vertical parabola, x is 280, y is equal to 80 square. See, what do I mean by parametric representation? X and y are expressed in terms of another parameter t. That is the meaning. That is, they are given indirectly. X is given as a function of t, y is given as a function of t. Is that clear? So ellipse, the parametric representation is x is equal to a cos theta, y is equal to b sin theta. Hyperbola is a secant theta, b tan theta. Rectangular hyperbola is ct, c by t. And for asteroid, it is a cos cube theta and a sin cube theta. Of course, you have to know again all these parametric representations also, right? So in this, I will be seeing 2 problems and to find out the evolute. So the first one that I'm going to take one is find the evolute of the parabola x square is equal to 4ay. This is the question. So whenever you are asked to find the evolute, 4 steps are involved. What are the 4 steps? Step number 1, write the parametric form. Step number 2, find x bar, y bar in terms of parameter. Step number 3, eliminate parameter. And step number 4, replace x bar and y bar as x and y. So I'm going to explain these steps one by one. So first step is write the parametric form. What is the parametric form for x square is equal to 4ay? X is equal to 80 and y is equal to 80 square. So that is the first step. What is the second step? You have to find out x bar and y bar. So for finding out x bar and y bar, I have to use the formula. What is the formula? Do you remember the formula? This is the formula. X bar is x minus y1 into 1 plus y1 square by y2, and y bar is y plus 1 plus y1 square by y2 is the formula, where y1 is dy by dx, y2 is d square over dx square. So for finding x bar and y bar, what I have to calculate? dy by dx and d square y by dx square. Okay, but here I am having the parametric form. Y is not in terms of x, y is in terms of t. Like that, x is also in terms of t. So what I can find out is dx by dt and dy by dt only I can find out. So that is the next step, dx by dt. What is dx by dt? 2a. dy by dt. What is dy by dt? 2at. So after finding out dx by dt and dy by dt, I can find out dy by dx. What is dy by dx? dy by dt by dx by dt. So I am just substituting the dy by dt value and dx by dt value and getting the answer as t. So y1 equals t. What is y1? dy by dx is equal to t. So first derivative I found. I have to find out the second derivative. What is the second derivative? D square y by dx square. What is the meaning of d square y by dx square? Differentiate the first derivative with respect to x. But how is the first derivative? The first derivative is not in terms of x, but it is in terms of t. So therefore, if I want the derivative of t with respect to x, I have to differentiate t with respect to t into dt by dx. That is the formula. So d with respect to t with respect to t is 1, and derivative of dt by dx is nothing but 1 by dx by dt, which is 1 by 2a. So your y2 is 2a. So I got y1 value, which is t. I got y2 value, which is 1 by 2a. Now I have to substitute these values of y1 and y2 in the formula for x bar and y bar. So what is x bar? X minus y1 by y2 is 1 plus y1 square. Y bar is y plus 1 by y2 into 1 plus y square. So substitute y1 value and y2 value. And when you substitute everything, you will be getting x bar as minus 2at cube. From this, what will you get? T cube as x bar by minus 2a. Okay. So I found the parameter in terms of x bar. Like that. Take the next formula, y bar. Y bar is what? 1 y plus 1 by y2 into 1 plus y1 square. Substitute y1 value and y2 value. When I do that, I'll be getting y bar as 3at square plus 2. From that expression, find out what is t in terms of y. So we'll be getting t square as y bar minus 2a by 3a. So now look at equation 3 and 4. Equation 3, I got t in terms of x bar. Equation 4, I got t in terms of y bar. So two steps are over. What are the first step? Expressing in parametric form is over. Next one is expressing x bar in terms of t, y bar in terms of t. So two steps over. What is step 3? Eliminate the parameter. So what do you mean by eliminate the parameter? I have to remove, I should not have t in my equation. So how will I eliminate t? For that, in the first equation I am having t cube, second equation I am having t square. So if I want to eliminate t, I have to make the powers of t same. When will the powers of t same? If the power is t power 6. So how will I get t power 6? If I square equation 3, I will get t power 6. If I cube equation 4, I will get t power 6. So square equation 3 and cube equation 4, and then when you simplify, you will be getting, your t will be eliminated, and you will be getting an equation 27a into x bar square equals 4 into y bar minus 2a the whole cube. Right? So third step is also done. What is the third step? Obtain x bar, an equation in terms of x bar and y bar. So that is given by equation number 5. So how I have got this? By eliminating t, I have removed t, I have got an expression, I have got an equation which involves only x bar and y bar. That is your step 3. And the last step is replace x bar as x, y bar as y. That is going to be the required evolute. So I have replaced x bar as x and y bar as y, which means the answer is 27ax square is equal to 4 into y minus 2a the whole cube. That is the parabola. This is the evolute of the parabola. X square is equal to 4a. Now, the evolute of the parabola y square is equal to 4ax is same answer with just one small change. Just interchange x and y. Got it? The evolute of the parabola y square is equal to 4ax is nothing but same expression where x and y are interchanged, which means the evolute of the parabola y square is equal to 4ax is going to be 27ay square is equal to 4 into x minus 2a the whole cube. So you'll be getting a very similar answer where the roles of x and y are interchanged. The procedure is same way you have to proceed. You will be getting the answer. Yes. So we will see one more problem, evolute of the ellipse. So what is the first step? Write the parametric form. What is the parametric form of the ellipse? X is equal to a cos theta, y is equal to b sin theta. So here the parameter is theta and not t. So what I should be finding out? Dx by d theta I have to find out, dy by d theta I have to find out. Then find out dy by dx, which is dy by d theta by dx by theta, which is minus b by a cot theta. So y1 is minus b by a cot theta. Next, I have to find out y2. What is y2? Derivative of y1 with respect to x. But then y1 is not in terms of x, it is in terms of theta. So differentiate first with respect to theta into d theta by dx. But what is d theta by dx? 1 by dx by d theta. So substitute everything. You will be getting the next value of next derivative, namely y2, which is minus b by a square cosecant cube theta, is minus b by a square sine cube theta. So y1 is minus b by a cot theta and y2 is minus b by a square sine square theta. So after having found y1 and y2, substitute these values in the center of curvature formula, namely x bar and y bar. You will get x bar as, after all the calculations, cos cube theta into a square minus b square by a. So from that, I'm finding out the value of parameter in terms of x bar, which means cos cube theta is ax bar by a square minus b square, or cos theta is ax bar by a square minus b square, the whole power 1 by 3. Right? Similarly, find out y bar. Same way, by substituting y1 value and y2 value, you will get sine cube theta as by bar by b square minus a square, or it is sine theta is by bar by minus of a square minus b square, the whole power 1 by 3. So what I have obtained? I have obtained cos theta in equation 3 and I have obtained sine theta in equation 4. Next, our aim is to eliminate this theta. What is the equation involved in eliminating cos and sine? Is cos square theta plus sine square theta equals 1. That is the relation which eliminates theta. So make use of that relation. Cos square theta plus sine square is equal to 1. So instead of cos square theta, you substitute the respective value. Instead of sine square theta, substitute the respective value. So remember, sine theta, I'm getting it as negative. So when I square it, that minus sign will go off. So you'll be getting like this. So you'll be getting an equation of the form equation 5, namely ax bar power 2 by 3 plus by bar power 2 by 3 equals a square minus b square, the whole power 2, 3. The third step is obtain an equation in terms of x bar and y bar is obtained. Now, last step, change x bar as x, y bar as y. So you'll get the required equation, which is ax power 2 by 3 plus by power 2 by 3 equals a square minus b square power 2 by 3. So that is the evolute of the ellipse. So the same procedure I have to follow for hyperbola. What is the equation of a hyperbola? X square by a square minus y square by b square is equal to 1. This is the equation of the hyperbola, whose parametric form is x is equal to a secant theta, y is equal to b tan theta. So just proceed how you have done ellipse problem. Same way when you proceed. In ellipse problem, you got cos and sine. In hyperbola problem, you will be getting secant and tan. So for cos and sine, the relation is sine square theta plus cos square theta is equal to 1, which you have used to eliminate theta. For hyperbola problem, since secant theta and tan theta you will be getting, the relation involving secant theta and tan theta is secant square theta minus tan square theta equals 1. Is the relation that you will be using in order to eliminate theta. So when you do that, your answer is very similar to ellipse answer with a just change in sign. That is, you'll be getting the answer for hyperbola as ax power 2 by 3 minus by power 2 by 3 equals a square plus b square power. So same way I have to for asteroid also. So any problem if you take, you should know its parametric form, then find out dy by dx, b square over dx square, find x bar, find y bar. After that, eliminate theta and finally replace x bar and y bar by x bar. So this is the asteroid problem, right? So asteroid problem goes like this. So same way for asteroid problem, if x is equal to a cos q theta, y is equal to a sin q theta, y1 is minus tan theta, y2 is, you are getting an expression 1 by 3 a cos power 4 theta sin theta. Just substitute everything. you will be getting x bar as a into cos cube theta plus 3 cos theta sin square theta, and y bar as a into sin cube theta plus 3 cos square theta sin theta. So like the previous two problems, I cannot find out the parameter in terms of x bar easily. In the previous two problems, I was able to find out t in terms of x bar. I was able to find out cos and sin in terms of x bar and y bar. But in this problem, I'm having two terms in terms of theta. It is not easy for us to find out theta in terms of x bar. So what should be done is, we have to do some adjustments. What is adjustment is, add the equations 3 and 4. So obviously you have to remember all these procedure, only then you'll be able to solve the problem. So when you just add equation 3 and 4, you'll be getting a simplified form. What is that? X bar plus y bar equals a into cos theta plus sin theta the whole cube. Like that, subtract. X bar minus y bar is a into cos theta minus sin theta by whole cube. Even in this situation, I cannot express sin and cos in terms of x bar and y bar. So I have to go one more step further, namely cos theta plus sin theta is x bar plus y bar by a power 1 by 3, and cos theta minus sin theta is x bar minus y bar by a power 1 by 3. Again, what should I do is, one more simplification has to be done, which is cos theta plus sin theta the whole square plus cos theta minus sin theta the whole square. So only when I consider this, theta will be eliminated. So I have to do calculations in such a way that the parameter has to be eliminated. So in this particular problem, first what you should do is, after finding x bar and y bar, you have to add x bar and y bar as the first step, subtract x bar and y bar. After that, you have to square x bar and y plus y bar term and x bar minus y bar term. Only then your theta will get eliminated, and you will be getting the final equation as x bar plus y bar the whole power 2 by 3 plus x bar minus y bar the whole power 2 by 3 equals 2a power 2 by 3. Then replace x bar and y bar as x and y. You will be getting the answer as x plus y the whole power 2 by 3 plus x minus y the whole power 2 by 3 equals 2a power 2 by 3. Okay. So the two parabolas have the same procedure. Ellipse and hyperbola have the same procedure. Like that, asteroid and rectangular hyperbola have the same procedure. So rectangular hyperbola already have given you xy is equal to c square. That is the equation, and the parametric form is also discussed. So I have to proceed. There is the procedure for rectangular hyperbola is similar to procedure of asteroid. Remember, I repeat once again, the procedure for parabola x square is equal to 4ay and y square is equal to 4ax is same. The procedure for the ellipse and hyperbola are same, and the procedure for asteroid and rectangular hyperbola is same. Okay, and the answers is slight variations in the sign, positive sign. So for rectangular hyperbola, your locus will be x minus y the whole power 2 by 3 plus x plus y the whole power, x plus y power 2 by 3 minus x minus y the whole power 2 by 3 is equal to 4a the whole power 2 by 3. That is the final answer for x plus y power 2 by 3 minus x minus y the whole power 2 by 3 equals 4a power 2 by 3. Right? So these 6 questions, for these 6 questions, you should know the parametric form. Now the 7th question is, prove that the evolute of the cycloid. You are given a cycloid. Here in this case, the cycloid equation itself will be in the form of parametric form. So step 1 is not at all required. Already in the question itself, it will be in the parametric form. So you have to simply find out x bar and y bar. Again, what is the question is, prove that the cycloid, evolute of the cycloid is another cycloid. So always your cycloid equation will be in parametric form only. So the given cycloid is x is equal to a into theta minus sin theta and y is equal to a into 1 minus cos theta. So it is already in the parametric form. So step 1 not required. Step 2 only I have to do. What is step 2? Find out x bar in terms of theta. find out y bar in terms of theta. Since you are asked the answer also has to be in cycloid, that also has to be only in parametric form, which means in this question I need not eliminate the parameter. I have to simply find x bar in terms of theta, y bar in terms of theta, and just replace x bar and y bar. So when you do that, you will be getting the answer as the evolute as a into theta plus sine theta and minus 2a into 1 minus cos. That will be the answer for the seventh year. Okay, so I think you are okay with the first units. So in the first unit, mainly matrices, I have discussed only Cayley-Hamilton theorem. Whereas in the second unit, namely differential calculus, I have concentrated only on evolute. So evolute, you can just work out all those 7 problems under evolute. Definitely you will be getting one question, right? And in the Cayley-Hamilton theorem, verification of Cayley-Hamilton theorem and hence finding A inverse or A power 4 will be asked. So you can try that also. Is that clear? So this is the 2018 question paper which I have made, 2018 question paper I have. So in that part A, the first question is find the characteristic equation of the matrix is asked in 2 marks. So it's a 3 by 3 matrix. So you know the formula for characteristic equation for a 3 by 3 matrix. Write the formula, find the constants and give the answer. Then verification of Cayley-Hamilton theorem for a 2 by 2 matrix is asked in part A. So you can answer that also. The third question is radius of curvature is asked. And here they have given you the answers itself. See, y dash, if y dash is 3 by 2, y double dash is 3 by 4a. You need not calculate radius of curvature. First derivative and second derivative is already given to you. What you have to do is simply use the formula. What is the formula for radius of curvature? Rho is 1 plus dy by dx square, the whole part 3 by 2 by d square y by dx square. So dy by dx is given to you readily. D square y by dx square is also given to you readily. Just substitute the values in the formula. You will be getting the value for radius of curvature. So please, wherever formulas are available, you have to definitely memorize the formulas. Then only you can solve the problem. And the fourth question is they have asked circle of curvature. Again, I have given you the formula for circle of curvature also. For circle of curvature, whatever is given is x bar is given, y bar is given, and then rho is also given. It's not actually, it is not p, it is actually rho. So for circle of curvature, what is the formula? X minus x bar the whole square plus y minus y bar the whole square is equal to rho square is the formula, in which x bar is given, y bar is given, rho is given. Just substitute and then you can find out the circle of curvature. So we have just seen only the 2 units. So I am seeing, so we will see part B questions in first 2 units. Part B question, the first question is find the inverse of the matrix. Inverse of the matrix. You are given a 3 by 3 matrix using Cayley-Hamilton theorem. So this is what we have discussed. So other part, as I told you, I have discussed only 1/2 of your first unit. So only one topic I have discussed. So from that topic, you are got one question, namely use Cayley-Hamilton theorem. You need not in fact verify. You can directly find out A inverse with the help of Cayley-Hamilton theorem. So that is your first unit. The second unit, radius of curvature is asked. Show that the radius of curvature. In fact, the answer is given. You have to find out the radius of curvature by using the formula. Find dy by dx, d square y by dx square, and then substitute the formula. A point is given, substitute the point and show that the answer is A by 2. And also circle of curvature is asked. What is circle of curvature? Circle of, show that. So the answer is also given to you. So what is the circle of curvature formula? X minus x bar square is y minus y bar square is equal to rho square. So in the place of x bar, you are having 3a by 4. In the place of y bar, you are having 2a by 4. And in the place of rho square, you are having a square by 2, which means the rho is a by root 2. So everything is there. You have to find out radius of curvature. You have to find out center of curvature. You know what is your radius of curvature. It's already given the question, a by root 2. Center of curvature is also given that 3a by 4 and 2a by 4. You have to prove those things. then you are through with the problem. So first part is actually radius of curvature, circle of curvature. So either you can attempt that or evolute of the hyperbola. That is also we discussed evolute. So evolute is a definite question. So we have seen the first two units. So whatever I have discussed, that is namely in the first unit, be thorough with. You have to be completely thorough with the. You have to be thorough completely with the Cayley-Hamilton theorem. Practice very well Cayley-Hamilton theorem from the first unit. From the second unit, practice problems under radius of curvature, center of curvature, circle of curvature, and evolute. Evolute the standard 7 questions. Apart from the 7 question, there is one more question under evolute, which is practice. For that, the curve will be in the parametric form. It will be given the question, you can solve that. So just concentrate more on the first 7 formulas, standard results. What are the 7 formulas under evolute? 2 parabolas, ellipse, hyperbola, asteroid, rectangular hyperbola, and finally cycloid. So at least be thorough with these 7 problems. You will be able to get a minimum of 8 marks in each unit. Okay, that's it. So please practice these problems well, and we'll see in the next session, day after tomorrow, units 3 and 4. If not full 3 and 4, third unit and half of fourth unit at least we will discuss. And in the last session, we will see the remaining units. Okay, so all the best. You can just refer to any book and try to work out the problems as seen. Only then you will be finding it easier. Thanks, students.